Here's a quadratic to solve, and unlike the last chapter, we're not going to be able to factor this thing. But we still want to start with the idea of making one side equal to 0 before we do anything else. Because in these types of problems, I have not only an x squared, but an x as well. Unlike in the previous section, 2.2, where I just had a simple x squared or a quantity squared. This has got two different kinds of x's, and so the only game in town, always, is to start by making sure one side equals 0. The easiest way in this case to do that is to subtract 1 from both sides of the equation. I'm going to solve 9x squared minus 3x minus 1 equals 0. Now, the next thing I'm going to do is start to bust out this quadratic formula, which is opposite of b plus or minus that discriminant we talked about, which we know is b squared minus 4ac all over 2a. This is a huge, again, jungle of symbols and craziness, and if you try and do it all at once, it can get a little crazy, especially the first couple times. So I'm going to break it down like this. Start by finding that discriminant. This is the exact same problem I did in example 2. So we know that b squared is 9. We know that negative 4ac, that this is the part that I would do in my head. Here's my head again. Negative 4ac. This ended up being positive 36. So that discriminant ends up being 45. So now I'm going to look at this equation, and this craziness, I know it's just going to be a 45. So let's do the rest. The opposite of b is positive 3, plus or minus square root of 45. That was b squared minus 4ac, all over 2 times a. Do that calculation mentally. 2a in this case is going to be 18. Now this is looking pretty familiar. This is like the other example on this same sheet. It's kind of gross looking. I don't like this radical. Let me focus on that part first. There are more mental calculations. That's a big head. Root 45, I can rewrite that. I'm thinking of all those perfect squares that I know about, and I'm trying to find the biggest one that goes into 45. Root 45 is the same thing as root 9 times 5. Square root of 9 is 3, root 5. So now x is going to equal not 3 plus or minus root 45 over 18, but 3 plus or minus this simplified version of root 45 over 18. And then I'm going to look at all these numbers on the outside of the radical. The guy inside the radical is safe. He's in his little safe house. But these guys, if they have a common factor, I have to divide it out. 3, 3, and 18, they can all be divided by 3. So I'm going to do that. 1 divided by 3 is 1. Plus or minus 3 divided by 3 is 1, but there's a root 5 here, so I could just put a root 5. You can put the 1 in front if you want to, but you don't have to. And this divided by 3 is going to be 6. So this would be one correct answer. Alex might want you to write it like this. 1 plus root 5 over 6 as one answer. 1 minus root 5 over 6 as another answer. That's one thing they might have you do. Or they might have you break that up to be like a 1, 6, and 5 root 6. So 1, 6 plus root 5 over 6, 1, 6 minus root 5 over 6. I prefer this answer. Alex always shows the answer like this. It should accept both. You should be familiar with both. I don't care which one you do. But this is like a nice combination of all the things on this page we're having to use. Opposite of b squared minus 4ac going on, mental calculations, simplifying radicals, reducing fractions. This has got it all. This is a great problem. Be very careful with your signs. Don't rush through these because you'll make dumb mistakes. Just make one side 0. Take your time with that discriminant. Plop in the other values. Simplify. It's going to be good. Good luck. Oh, there's another video on this same page where I give a decimal answer. These are considered exact answers.